So I'm Tanay, and we are Tryon Labs, tryonlabs.ai. So one thing is like what I'll just quickly tell you what we are working on. Then all of these guys they discussed the virtual try-on technology, but I'll actually take you through what we are actually using in the virtual try-on technology, the underlying models. So yeah, at Tryon Labs we are building those diffusion models which comes into play when these people they use it for production. I mean serving the D2C brands or the consumers whatever. So we are building those models, so and we are serving them. So right now we are not directly working with the D2C brands or the e-commerce brands. We are working with the people who are building fashion applications, or people who want to consume the pre-built virtual try-on models. Okay, so yeah, we are going to first discuss on what exactly virtual try-on is, where we stand today in terms of technology, and what we have done in the past. Then I'm going to just introduce you one of the models, AI models that is not currently widely being used, but this is, I believe, something is going to be there in next 3 or 4 or 5 months, that will be widely used. Then some open source models, then our solutions, the APIs that we are serving right now, and the possibilities, and then Q&A. So we'll get started. Yeah. So okay, before starting, I'll do a quick survey kind of thing. So how many of you are software engineers? Can you just raise your hands? And how many of you are working in the space of actually the deep learning or machine learning? Anyone? Okay. And yeah, anyone working on building D2C brands, or uh, anyhow consuming the virtual try-on technology? Okay, cool. Uh, got it. So yeah, so already these people they told you what virtual try-on is. So you have a picture of a person, you have a piece of garment, and you wrap that piece of garment around that person. That's what virtual try-on is, and you can see how seamless it is. The picture looks so realistic. So it can go the other way around as well. So one of the problems here is, so let's say you want a sleeveless garment, and the person who is in the picture is wearing a full sleeve garment. In that case, you'll need to generate those hands, right? So that those hands they should match the skin tone of the face. They should, I mean, and then they should blend seamlessly. So that's the issue, and that's why we use diffusion models. We were using GAN models. We are using diffusion models, and that's the reason we are using generative models. Okay, so this is the general timeline of how we came here to diffusion models. We started with AR. Okay, AR is augmented reality. People have already talked about it, But what is wrong with AR? The wrong AR is wrong for virtual try-on. Why? Because, for example, Lenskart has been using AR for the try-on of spectacles, but this is a solid object. Garments they are free flowing objects. They have creases, they have curves. You can't use AI to seamlessly blend it uh, on top of a human. So we have AR, then we add 3D AR, but and again, one of the other problems with AR is you need to create with 3D AR, you need to create that particular garment in 3D, which takes a lot of time, which takes a lot of man hours, and which is computationally and human, both it's in both terms it's expensive. Then we have GANs. Okay, so this is a game changer now in terms of virtual try-on, because now without the help of the person sitting there in the back building those 3D garments, we are able to just take the image of the garment, and then we are able to transfer it to the person. So there are a lot of GAN based models. PBAFN is one of them. I will discuss that later. We have explicit warping with GANs, and then diffusion models. So after GANs, what came next was, so explicit warping is when you warp the garment separately. So you have a piece of garment, and the hands are like this, the posture of the waist is like this, but then you have a person in another pose. So you need to change the pose of the garment. So you need to warp the garment. So that's something that we call warping. Okay, so you need to change the pose of the garment. So we used to use GAN for that. and that would be explicit warping. And then there would be some areas that we need to regenerate on top of it. And for that, we were using diffusion models in order to regenerate properly, blend those areas with rest of the background, rest of the human body. And then finally, where we are at right now, we have implicit warping models in diffusion. So we don't need to use GANs. We use diffusion models to implicitly warp the garments. So they are much, much more efficient. But because one unified model is running now to generate your whole virtual try-on image, that is one thing. And these explicit warping garment models, they take a lot of different kinds of input. You need dense pose, you need human parsing map, you need open pose. There are somewhere around 7 models that we were using before uh, before reaching virtual try-on actually. So computationally expensive. Somewhere it was around a minute, and now we have reached with these 25 seconds for one virtual try-on. So that's a huge difference. Okay, so coming back to the AR thing, so you can see here the results. And this is something I've popped out from a website who's actually using it in production. But do they look anywhere near production ready? You can see how it's going off, how the background of this is looking. So they are using it for serving their consumers. This is not something that will work out in the future, because now that we have better tech. Okay, so the problem with GANs was, you can see, first of all, I could not get a better resolution picture than this, because GANs do not generate better resolution picture than this. Okay, and you can see how the patterns are not getting regenerated. And then you can see in this original garment, this is the garment that she's wearing, the model is wearing, and you can see in the generated garment also it removed the sleeves, right? So that is another issue with this. And in the subsequent pictures, yeah, the neck is not very well generated. There are these issues, but still, uh, the one advantage over AR is, you can see here the skin has been regenerated, how, even though it was blocked by the previous garment in the original picture. Okay, so this is one of the explicit warping diffusion model. Here we are using GAN plus a diffusion model, in order to generate the image. So this is the original, the previous one we saw, one of the GAN based method. This is one of the in-painting method where the color are completely changed, and this is a model called DCI Vuitton. Okay, it comes from China. No one knows about it, but apparently it was a very good, one of the best research out there uh, a year back. So maybe year and a half back. So what we are doing here is, we are using GAN model, and we are warping we are generating the warp of the garment. So we wanted to bring it from this to this. Now we paste this picture in the occluded area, and we generate the rest of the body using diffusion model. So much better blending. It will give much better blending than just GAN, and it would preserve the garment properties as well, because we are applying diffusion on the whole picture. So if you know what diffusion is, everyone is going diffusion. But what we do is, we denoise the picture. We put a lot of noise in the picture, then we denoise the picture, and after denoising we get the result. So it's a Gaussian noise, and we kind of, in each step we keep on denoising, and we get the result. So that's what diffusion is on a high level. Then we have one of the implicit warping model in diffusion, and this architecture is of a open source model. The weights are also open source. You can just go on and try it out. So yeah, so in the previous model we saw there was a separate GAN, a separate diffusion model, but in this model, this whole one model is diffusion, and this concept is called the parallel unit. Okay, so in diffusion we mostly use unit, and this is one of the models where we are using two units in parallel and applying diffusion on a unified network. And there are a lot of things over here. We can, in this particular model, we can also give text embeddings. So let's say you want to tell your model, so you'll have to train it first in that way. It's not yet trained now, but we can possibly train it. So let's say you want to keep the jacket open, okay, and you want to keep the jacket closed. So you can give in the text embedding that you want the jacket closed or jacket open, and then it will, if it's trained in that way, it will be able to, in the final virtual try-on result, it will be able to keep it open and closed. So these are the possibilities with these kinds of models. Okay, so this is one of my favorite model, try-on diffusion, and actually at Try-on Labs we also did a open source implementation with this model. So this was a research published by Google in June 2023. Okay, and this was the very first model where they gave out the research of implicit warping. This is where the implicit warping comes from. And you can see this is one of the units and this is another unit, and how they are giving the occluded picture. So what would they would do is, I'll maybe later explain you the architecture just from the top a little bit, okay, just for the fun of it, but yeah. Yeah, okay. So what we do in this network is we give a occluded picture. So let's say I want to perform virtual try on my own picture. Okay, I would just I will take my picture. I would just crop out this area, and I would have some of the other things. For example, I would have the pose of my body, which would preserve how I was standing before, and then yeah. So that's what I'll do. I'll give this image to that network, and it would regenerate this area again completely from scratch. Okay, and I would be giving the noisy image as well of my own, because then it would denoise it and change the garment on top. Okay, and there's so we were previously warping the garment explicitly, but in this network we are giving the segmented garment. Now one more advantage in this implicit models are, you before you needed a flat lay of a garment image, okay, but now you don't need that flat lay anymore. What you can do is you can have the garment in any pose. For example, someone else is wearing a t-shirt, I liked it, I click that picture, it would segment it out. Okay, now the garment would be in any other pose, and my and I want to put it on myself, and I can change the pose of the garment and I can put it on myself. So that's a game changer, because most of the pictures you see out there on Flipkart, Myntra, Zara, they are not flat lays. They are pictures that models are wearing those garments, right? So we can just take those pictures and use it in our AI models for our consumers to try on those garments. Right now, most of the companies, they are working on the cataloging, in the cataloging space. They are generating the catalogs for D2C brands. They are generating catalogs for e-commerce. They are generating catalogs for people who are third party merchants who are selling on those e-commerce platforms. But what our vision is, we want to bring this to the customers. Okay, we want to we want people to take their own images when they're sitting at home, and then try those garments on. So this is the model that is making it possible. Okay, so one of the best things about these models are, we have easy to collect data set. For example, like I told you, I have a picture of a person in one garment, and I want to put it on myself. So that's my data set. Before, my data set would have been, I have to take a flat lay, then I have to take a person who is wearing that a particular flat lay picture, the garment in the flat lay picture. If you don't know what a flat lay is, you just keep a garment on the table and you click a picture from the top. That's what a flat lay is. Okay, so you would need those kind of data set. But now that we are using this, it's much easier to scrape, because the internet is filled with such images. So these are the kind of images. These are three images that I picked from Myntra. Okay, so all your e-commerce websites, all your D2C websites, they are filled with these kinds of images. Okay, they necessarily would not have, the flat lays, but they have the image of the person wearing the same garment in two different poses, and that's essentially the data set for us. Okay, so this is our open source implementation. It's out there, it's open source. We have not released any weights yet, but this is what we are working towards. We are going to be releasing the weights. We will be open sourcing them, and we started implementing it, and within a month or something, we got somewhere around 200, 300 stars over this rep. So this is one of the foundational models that we have created from scratch, uh, and we have trained it ourselves. We are not using any other pre-trained diffusion model. So you can, if you want, you can just take the picture of this and go to our repo if anyone is interested in contributing to the code. If anyone wants to raise some issues, new feature requests, anything, so you can just go through this. Shall I go ahead? Okay, so that being said, now we are going to talk about the open source models that are out there, which, if even if you don't want to consume anyone else's APIs, even if you don't want to, build a model from scratch, let's say you decide to build an application, consumer facing application, or you want to build a business and cataloging, you want to start it out, you can use one of these open source models and use virtual try on in any of your applications. So we'll discuss this. Okay, one is DCI Vuitton. So I already showed you the architecture of the DCI Vuitton, where there was explicit warping and using GAN, and then another network, diffusion network, which was regenerating and blending those areas. So this is based on GAN. It's implicit warping, explicit warping. Okay, so this uses one of the in-painting networks. So the GAN network that is being used is called PBAFN. Okay. Now what they have done is, so PBAFN takes a lot of inputs. For example, it takes dense pose, it takes open pose, it takes human parsing map. So dense pose is a kind of a pose where even if you are wearing garment, it would get an estimate of your body. Okay, it will give you the body structure, how it looks, how your body looks without the garments. Okay, so it will give you an outline of your body. Open pose is something where you can get the key points of your elbows, wrist, shoulders, all the major key points. So there's that. And then we have to use human parsing map, which is one of the most computationally expensive tasks, because you segment each of your body part, each of the garment with a different color, and it takes time. So and it's difficult as well. So your upper body garment would be a different color, your lower body garment would be a different color, your wrist would come in different color, and we use all of these things to generate the agnostic images. The agnostic images are the one where I showed you that they are cutting off the part of the image which they want to regenerate, right? So those are the agnostic images, and we used to create these agnostic images because we want to know, right, where we want to cut off the body from. So yeah, so that network is called PBAFN, and then they distilled the model. Okay, they distilled the model so that all these inputs, they are not needed now. Okay, we use PFAFN, so it's parser free AFN. Okay, so parser free AFN is what, you don't need dense pose, don't need a open pose, you just need to give the image. There will be a knowledge sharing between two networks. You'll train another network called PFAFN, and you'll use that network for finally generating your images. And then you can give it to diffusion. So that's one of the benefits of using DCI Vuitton. And one of the major benefits is the weights are open source. So you can just go to their GitHub repo, You can search DCI Vuitton, you can go to their GitHub repo, you can download the weight, try out the network for yourself. But still you'll need to spend a lot of time on setting those different networks up before you give the image to DCI Vuitton. You'll need to pre-process your human image a lot. Try-on diffusion, we just talked about it. So if trained enough, so Google trained it with somewhere around 3 million images. They only have the power to do that. And they trained it on 880 GB, 8 GPUs of 880 GB GPUs, and they trained it for somewhere around 8 days. One network, they trained 3 network to increase the resolution step by step, and that's how they did the training. And yeah, that's not something that is very much possible for us right now, but we have already started our training. We are achieving some good results there. And weights are not open source. We have one open source implementation. You can get maybe one or two more open source implementations, which are very much similar to ours. But yeah, I'm proud to say that we were the first ones to bring out to open source our implementation for this particular paper. Okay, so this is a pretty interesting network. It's much similar to Tryon diffusion. It's a successor of Tryon diffusion and outfit of the day. Okay, so this came around 2 months after Tryon, 3 months after Tryon diffusion came, and this is the network where you can give the text embeddings also. Okay, what you want to do is it's not there yet. I mean, the weights are not there for the particular use case that I told you about. The jacket's open, the jacket closed, or maybe the shirt tucked in or shirt tucked out. But that is very much possible if you train it that. Okay, if you train it on that data set. So yeah, a very basic model is open source by the authors. Okay, it is, so there are few basic data sets out there. One is HD Vuitton data set. Okay, so there's a company called Zolando which has open source that particular data set, which most of the people use for their open source implementations, because okay, I'll tell you why. Okay, so I don't actually have a chocolate, but this is a question: why is it difficult to have a brilliant open source Vuitton model currently? So if anyone would like to answer that, I mean, there are so many difficulties, but there is still one challenge. Even why Google cannot open source their model. Anyone? Sorry? Exactly, yeah. So they must also have scraped the whole of their data set, and they would also again be facing the issue of data infringement if they open source their model. So there are only few fashion data sets out there. One of the best one is Vuitton HD, and there are only 12,000 images. Google trained it on 3 million images. Where did you get that 3 million images? They obviously scrapped the internet, and that's what we are doing also. We can't even open source our model on that, right? So that's one of the issues that is there with Vuitton, that it's not getting open source. Any of the good models are not getting open source. Okay, now that I've taken you from open source to try-on diffusion and history of virtual try-on, so I'll just quickly give you tell you what we are working on. So this is our solution. So like I told you, we are not working with D2C brands. We are not working with e-commerce or third-party merchants. We are working with people who are enabling virtual try-on for these D2C brands, e-commerce spaces, and third-party merchants. We are working with them. So let's say if you want to build an application in fashion tech and you want to provide your consumers with an experience where they can perform a virtual try-on, you can just go on and use our APIs and not go through the hassle of training your own network or setting up all those networks I talked about, deep learning networks I talked about, So yeah, you can do that. So we are just providing APIs. So this is one of our results from the model that we trained. You can see this is the original person. This is jacket, and this is our result. It looks pretty seamless. I mean, you can see the texture being preserved. You can see the number of buttons are getting preserved. The collar, it understood what the collar would look like if you open it up. So yeah, this is where we are right now. This is how seamless the experience is. Then we are also giving out the cataloging APIs. So cataloging is something where uh, uh, you, so how mostly people are not using virtual try-on for cataloging back. Okay, virtual try-on is still yet to reach that level where people can productionize it or building catalogs for merchants. Right now, what they are doing is they are using they are swapping the models. So let's say your merchant or your D2C brand, it gives you an image of this mannequin, and this mannequin is wearing a garment. They would just they would keep the mannequin as it is, they would perform outpainting, and they would remove these things, they would remove the background, and they would replace it with a human. And you can see there is no change in the garment, there is not a single change in garment, because when you are performing virtual try on, you are generating everything through diffusion, right? So you are missing, there will be hallucinations, you might generate 5 buttons instead of 4 buttons. You might miss out on a texture, you might not be able to retain the textual information written on the garment. The A might become double A, because again we are generating everything, right? So we don't want to risk that right now with cataloging, with generating, because these people, they are very specific about how the results that they want. Okay. And yeah, so you can see there's no change, and yet we are getting a good result. So these are the models that are being used, and underlying models for these are stable diffusion models, the in-painting models of stable diffusion. Now we have Flux, which came a month back, which is even more realistic than this. So again, this is the picture generated by one of our models, not the model that we trained, the one of the open source model that we are integrating with our APIs. Okay, so you can see the generation in the hair, because in the prompt I wrote curly hair. Okay, you can generate background of whatever you want. You can generate it on a beach, you can generate it in a park, whatever you want. So yeah. So this is the try on AI documentation. So if you ever want to explore our APIs, so we have created it like this. So you can just go on, play around in the playground. You get free credits also to try these APIs out. You can directly integrate if you are building some applications. So yeah, this is a virtual try on API, and this is the cataloging API. Very straightforward, and yeah, you can directly integrate it in your applications. We also have uh, a try on AI playground, which is kind of fun also. So this is I'll let you click the pictures later, but this is our try on AI playground. Okay, so we have a picture of bunch of garments, and here is where you can upload the picture once you sign in. So but yeah, you can try these pictures for without signing in. So you get some credits for free. You can upload your own picture, you can try out the bunch of garments that are listed here, and you can use our APIs to integrate even more garments that you want. You can push the garments from by using our APIs using your account and our APIs, you can directly push it into the UI. Okay, so for example, this is the t-shirt, and I want to try it on this person. I would just do try on, and you can see the hallucination over here. So we are not still there yet, but we are getting there. I'll show you another example. Okay, so again you see this woman was wearing a full sleeve shirt, but the hands have been generated now, right? So this is one example. And by the way, this is not happening real time. We already have these results, so that's why they are running so fast. But usually it takes somewhere around 25 seconds to generate one virtual try-on result. So you can just head over here and try our APIs out. So also we are soon coming up with new sections over here. So one model that we are creating is where you can just take a selfie and you can give the approximate body size. For example, your waist, your abdomen is V size from the front profile, and a cylinder shaped from the side profile. You can give it basic measurements, and you can it would generate and you can choose the garment also. It would generate the body for you, it would generate the garment on top of you, and it would be much faster because we would already have those try-ons done in the backend. So it'll just fetch one of the bodies that match to your skin color, which match to your requirements, and you will just replace your head with the body. Okay, with the head that was before on that body, and you'll have a virtual try-on result within 2 or 3 seconds. So that is something that we are coming up with. Then we are also going to integrate the cataloging APIs over here, where you can upload your own picture. Then you'll keep the garment constant, and you can just replace it with AI generated model and AI generated customized background.
If you're serious about a career in AI, follow Deep Tech Stars on your favorite social media platforms.